So let's say we want to find the greatest common factor of 36 and 60. Well, why don't we just start out by writing out some of the factors of 36 and 60 respectively, and then we can just find the greatest common factor. So the factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4, nothing, 5, nothing, 6 and 6, and then 9 and 4. So these are all the factors of 36. And now let's write out the factors of 60. So we have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 7 nothing, 8 nothing, 9 nothing. So these are the factors of 36 and 60 respectively. So now, what is the greatest factor between both of these? The greatest factor is going to be 6. What that means is that the biggest number that can be divided from both 36 and 60 is 6. Because, for example, we can divide 36 by 9 and we get 4. 36 divided by 9 is 4. But we can't divide 60 by 9 and still have a whole number. That's just not how it works. So that means the greatest common factor of 36 and 60 is 6. Now, this idea of finding the greatest common factor of two numbers is pretty simple, but it's actually really important in math, in everything you do. Because if you want to fully factor an expression, you have to find the greatest common factor of all of the terms. So the two terms in this expression are 12x and 20. So what is the greatest common factor of 12x and 20? I'll give you a sec. So in other words, what is the greatest number that we can divide 12x and 20 by and still have a whole number? So we can start out with the coefficients of each term and figure out what the greatest common factor of the coefficients is. That's the first step. So the greatest common factor between 12 and 20, we can quickly find by writing out all the factors. So we have 1 and 12, 2 and 6, 3 and 4. And then for 20, we have 1, 20, 2, 10, 4, and 5. So the greatest common factor of 20 and 12 is 4. So that means we can divide both 12 and 20 by 4 and still end up with a whole number. So the next step to finding the greatest common factor between 12x and 20 is to look at the variables. The greatest common factor of these two terms is going to have the lowest degree of the two terms. So what I mean by that is, you might remember from grade 9 math, or maybe even grade 8, that this term is first degree because the x has an exponent of 1 above it. And this term is a 0th degree term because it has no variable. So that means that the greatest common factor is going to be of the 0th degree. It's not going to have any variables because we can't divide 20 by like 2x, for example. We can only divide 20 by a whole number because it's a coefficient. So therefore, the greatest common factor between 12x and 20 is simply 4. And now the next step to fully factoring this expression is to divide each term by the greatest common factor. So what we're going to do is we're going to divide 12x by 4, and we get 3x. And then we're going to divide 20 by 4, and we get 5. So knowing this, the fully factored form of 12x plus 20 is 4, which is our greatest common factor, multiplied by 3x plus 5. And notice how if we bring the 4 back into the expression, like we multiply 4 by 3x and we multiply 4 by 5, we are left with what we originally started with, which is 4 times 3x, which is 12x, and 4 times 5, which is 20. So that's how we know we're right, because our greatest common factor multiplied by the other factor should equal the original expression. You might remember that from the introduction video. So now we want to factor 4x squared minus 8x. And the first step is to find the greatest common factor of each term. So the first step to doing that is to find the greatest common factor of each coefficient. So the coefficients here are 4 and 8, right? Because we have 4x squared minus 8x. So the greatest common factor between these two numbers is equal to 4, right? Because we can divide both of them by 4 and still get a whole number. So the greatest common factor equals 4. Now the second step is to look at each term and find the term with the lowest degree. And that degree is going to be in the greatest common factor. So in this case, we have 4x squared, which is a second degree term, and we have minus 8x, which is a first degree term. So the lowest degree term is 8x, which has a degree of 1. So therefore, the greatest common factor of 4x squared and 8x is going to have a first degree exponent. So the greatest common factor is equal to 4x. So now all we have to do to fully factor 4x squared minus 8x is to divide each term by 4x, right? Because we basically just want to find an expression that we can multiply by 4x to get the original expression. So 4x squared divided by 4x is equal to x, because we can cancel out the 4's and then simply subtract the exponents, which is 2 minus 1, which just equals 1. And then negative 8x divided by 4x is equal to negative 2. So therefore, the fully factored form of 4x squared minus 8x is equal to 4x multiplied by x minus 2. And this is our final answer. Now, if we want to check our work, all we have to do is just use the distributive property to return to the original expression. So if we use the distributive property, we should get the original expression if we factored it correctly. So 4x multiplied by x is equal to 4x squared, and 4x multiplied by negative 2 is equal to negative 8x. So these two terms are equal, which means that we are correct. All right, so let's do another example quickly. So if we want to fully factor this expression, the first step is to find the greatest common factor of the coefficients of each term. So the coefficients of each term are 20, negative 12, and 4. So the greatest common factor between these three terms is equal to 4, right? Because we can divide each of them by 4 and still end up with a whole number. So the greatest common factor is equal to 4. And now this one is a little bit more tricky because the second step is to find the lowest degree term. But in this case, each term has more than one kind of variable. So each term has an x variable and a y variable. So what we need to do is we need to find the lowest degree term for each of the variables. So in this case, the x has a degree of 2 and the y has a degree of 1. In this case, the x has a degree of 1 and the y has a degree of 2. And in this case, the x has a degree of 1 and the y has a degree of 1. So basically, what we need to do is we need to identify which term has the lowest degree for both of the variables. So in this expression, this term right here has a degree of 1 for both the x and the y, which means that our greatest common factor is going to have a degree of 1 for both the x and the y variables, right? Which means that our greatest common factor is going to be 4 xy. So now all we have to do is divide each term by the greatest common factor, and then we'll get our fully factored expression. So if we divide 20x squared y by 4xy, we get 5x, and then there's no y since each y only has 1 degree, so we can just cancel those out. Then negative 12xy squared divided by 4xy is equal to negative 3, because negative 12 divided by 4 is negative 3. Then we don't have any x because we cancel those out. There's only 1 degree. And then y squared divided by y is just equal to y. And please, 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 always make sure that when you're dividing the terms, you include the negative sign if you're subtracting the term. And then when you throw everything back together, you won't have any problems when you're using your signs, because a lot of people mess up with the signs, and that's honestly, you're probably more likely to mess up a sign and get a mark taken off for that than you are to incorrectly divide something. Then the last step is 4xy divided by 4xy, and both of those terms are equal, so the factor for that term is 1. So if we want to write out our final answer, we get 20x squared y minus 12xy squared plus 4xy is equal to 4xy, which is our greatest common factor, multiplied by 5x minus 3y plus 1. So there we have it. There's the fully factored form. All right, so I hope that video was helpful to kind of show you how to fully factor polynomial expressions using the greatest common factor method. Now, if you want to go ahead and pause the video and just take a screenshot of these steps, it kind of summarizes everything that we went through. Now, as always, feel free to leave any questions or comments in the comment section below, and I'll catch you in the next one. Thanks for watching.